Good afternoon, everyone. As Polly said, I'm Michelle Nakaradi-Chapkus, and I'm Executive Director at Women for a Healthy Environment, a regional nonprofit here that through education and advocacy focuses on environmental exposures that impact public health. As an environmental health advocate and a very recent cancer survivor, thank you, I am thrilled and honored to introduce to you Dr. Margaret Kripke, Professor of Immunology and Vivian Smith Chair Emerita at the University of Texas, MD Anderson Cancer Center, and Professor Emerita at the Graduate School for Biological Sciences in Houston. Previously, Dr. Kripke was Director of the Cancer Biology Program at the National Cancer Institute's Frederick Cancer Research Center in Maryland, followed by an appointment as Chair of the Department of Immunology at the University of Texas MD Anderson Cancer Center in Houston, where it's a little warmer. And then she served as Executive Vice President and Chief Academic Officer. From 2013 to 2016, Dr. Kripke served as Chief Scientific Officer of the Cancer Prevention and Research Institute of Texas, which awards $300 million per year to support cancer research in Texas. She currently serves as a fellow of the American Association for the Advancement of Science and of the American Association for Cancer Research. Dr. Kripke's research interests center on the immunology of the skin and skin cancer, how skin immune function is modified by exposure to ultraviolet light, and how the immune system influences the development of skin cancers. Dr. Kripke has authored more than 250 scientific publications and served on many peer review panels determining research funding. She has received numerous awards for her very many research contributions. Due to her esteemed position within the scientific community, particularly as a champion of diversity in the workplace, the Margaret L. Kripke Legend Award was established by MD Anderson in 2008 to honor individuals who have enhanced the careers of women in cancer medicine and cancer science. In an interview last fall, Dr. Kripke said, as she was one of the authors of the President's Cancer Panel Report, that the Cancer Panel Report provides an overview of what the problems are, the major issues we saw at that time, and the recommendations for what to do now. Most of what we wrote then is still relevant now. The U.S. still has much work ahead to identify unrecognized environmental carcinogens and remove the toxins from our food, water, and air that are contributing to cancer and breast cancer. We've heard about those issues today, and we will certainly continue the dialogue about those pathways to prevention. Please, let's give a warm Pittsburgh welcome to Dr. Kripke.
The welcome is warmer than the weather, I'm afraid, but I'll take it anyway. Thank you so much. I'm impressed with the introduction. Good afternoon. I'm actually very, very pleased to be here today and really honored to participate in this event. And what I was asked to do today is to just tell you how I became interested in the issue of environmental carcinogenesis and why I think it's so important for trying to reduce the burden of cancer. Now, as an immunologist and cancer researcher, I have always been interested in some aspect of environmental carcinogenesis. As you have heard, most of my scientific career was devoted to studying the immunology of skin cancers induced by ultraviolet light. And of course, ultraviolet light from the sun, and I should add also tanning salons, is our most ubiquitous environmental carcinogen, and skin cancer is the most prevalent cancer of all. And what I was interested in was the question of whether the immune system provided any protection against cancer, because if so, this might be a new way to approach cancer therapy. And what I found was that in addition to changing normal cells into cancer cells, ultraviolet light actually alters the immune system in a way that prevents it from attacking skin cancers. Now, initially, the immune system keeps skin cancers in check, but with continued exposure, the immune response against skin cancer turns itself off and the skin cancers grow unchecked. Now, it turns out that the immune system has many mechanisms for shutting itself off, and the latest advance in cancer treatment today, the so-called checkpoint inhibitors, involves getting rid of these suppressive mechanisms and allowing the body's immune system to cure the cancer. And recently there have been some very spectacular successes using this approach, particularly in melanoma skin cancers. And of course, Jim Allison was recently awarded the Nobel Prize for his work in this area. So cancer immunology is probably the most popular topic in cancer research today. Now, my more significant encounter with environmental carcinogenesis came from my participation on the President's Cancer Panel a few years ago. Now, this is a 3-person panel appointed by the President, which is charged with informing the White House on the status of the war on cancer. Each year, the panel selects a topic for study and prepares a report. And one year, we decided to look at environmental carcinogenesis. Now, this was a really difficult decision, and in all honesty, I will tell you that I was not very enthusiastic about this as a subject. The negatives were that at the time, it was thought that cancers induced by environmental causes represented only about 6% of all human cancers. That was the figure that people quoted from the Dahl and Peto study, and everybody just believed that that's what it was. And so the question was, is 6% of cancers really worthy of the attention of the President's Cancer Panel? The second issue was that the subject was very controversial. And it's an emotionally charged issue, a politically charged issue, and we were concerned that this might be a diversion from an objective analysis of what was going on. And finally, as you've seen today in some of the data that Dr. Miller provided, there's lots of contradictory evidence. Some studies show an effect, some studies don't show an effect, and at the time, I don't think we had a lot of meta-analyses to help us try to address those issues. And so we thought, with all the uncertainty and the contradictory evidence, what conclusions were we going to be able to draw? And what would the message be to the White House and to the American public? On the other hand, the proponents pointed out that this is a subject that had never been studied in the 40-year history of the President's Cancer Panel. It was the subject of great public interest. People really wanted to know about that. And it got little attention from mainstream cancer research. If you look at the programs over the last few years from the big cancer research meeting, the American Association for Cancer Research meeting, there are no symposia, plenary talks on this subject. And at the time, less than 15% of the funds from the National Cancer Institute were spent on anything remotely related to environmental carcinogenesis. And the NIEHS, only less than 30% of their funds were spent on this also. They dealt more with toxicology and toxic things rather than cancer, with the understanding that cancer isn't our business, it's taken care of by the National Cancer Institute. And of course, the Department of Defense wants cures. Advocacy groups want cures. So this is a really understudied and underfunded area. And finally, one of the most compelling arguments to me was that 6% of cancer deaths is still, at the time, 30,000 deaths a year and 60,000 new cases of cancer per year that might be prevented. And if you're one of those, you, of course, would rather have it prevented rather than being one of the persons affected. So in any event, we proceeded. And I have to tell you, this was the most eye-opening experience for me that I probably have ever experienced, because I went in with a number of assumptions that I think are commonly held by most people in cancer research and probably most people who are part of the public. And the assumption number one is that chemicals would be tested before they are released to the public. I mean, naive it sounds to this group, but most people, I think, believe that somebody is not going to put something on the market that is actually toxic or carcinogenic. But what we learned was that since World War II, there are somewhere around 80,000 chemicals that have been put on the market, only a fraction of which have actually been tested for their carcinogenic event. And more than 3,000 of these are produced in very high volumes, which means over 1 million tons per year. And around 1,500 new ones are released annually. So that assumption turned out really not to be true. The second assumption was that carcinogens would be regulated. And that turned out not to be quite true either. There are many things that are on the IARC list of type 1 carcinogens that are not regulated in this country. There are chemicals that have been banned in Europe and banned in Canada that are still on the market here, and they are unregulated. I think the poster child this month is the herbicide Roundup. The third assumption is that if you have regulations, that those regulations would be enforced. And as we heard at lunch today, and as we know, this is also not always the case, that regulations are not necessarily followed. This is particularly true when it comes to agricultural pesticides and compounds used in agriculture. It's also not true in some industries as well, that there is insufficient protection even in the case when we have regulations. And so we said, well, why is this? Why does this happen? And the answer seems to be that it's because in the United States we use the reactionary approach to chemical safety. We only regulate after evidence of harm. And this is in contrast to other Western countries which use a precautionary principle, which requires proof of safety prior to release. So using the reactionary approach means that there's actually no incentives for developing safe alternatives. So that's where we are. So we wrote in our report that 6% was likely to be a serious underestimate, and that cancer due to environmental chemicals was likely to be a much larger problem than anyone was willing to admit. And this was, of course, a very unpopular conclusion. The White House didn't like it. The National Cancer Institute ignored it. And the American Cancer Society came out and lobbied against it. They were, of course, interested in lifestyle factors and thought it was a diversion of people's attention to focus on environmental chemicals. This is the blame the victim approach, I think, to cancer prevention. We had an interesting experience when we presented this to the National Cancer Advisory Board, which is the board that advises NCI. One of the board members asked the director, well, gee, this is pretty important. What is NCI going to do about this? And the director says, oh, we don't worry about that. There are other government agencies that take care of that issue. So that was the response that we got from the Cancer Institute. But if I think of what my life was like growing up versus what it is today, the difference is very striking. And you'll know how old I am when I read this list. We did not have an exterminator. We didn't use herbicides. We didn't have nonstick pans. We didn't have styrofoam containers. My mother had very few beauty products that she used, and we had few household cleaning products. So I couldn't help wondering, what was the impact of all of these chemicals on human health? Why have the incidence of childhood cancer and birth defects been increasing for the last 4 decades? Why is it that the onset of puberty has been occurring at a progressively younger age? And why is it that in the current epidemic of breast cancer, more than 80% of women have no family history of the disease? Could these be related to the ocean of chemicals in which we now live? And with all these important questions needing to be answered, we have to ask, why isn't environmental carcinogenesis a more prominent issue in cancer research? And I think the answer to that is complex. First of all, most cancer research have the same assumptions that I did, This is not a big problem. Cancers caused by environmental agents only represent a very small fraction of human cancers. You will still hear that repeated over and over again today. So for this reason, I've spent the last several years trying to raise the visibility of this issue within the cancer research community. And I'll give an advertisement here. I'm very happy to report that after some prodding, the American Association for Cancer Research is sponsoring a special conference on environmental carcinogenesis, June 22 to 24 in Charlotte, North Carolina. So I invite all of the interested parties to attend. Oh. Second of all, as you've heard from many people today, environmental carcinogenesis is really something that's very difficult to study. Epidemiology requires measuring things over long periods of time. It's time-consuming, it's expensive, and asking people to recall exposures over a lifetime is notoriously inaccurate, and so we need much better measures of exposure. We also need better tests for carcinogens, for what is a carcinogen. We cannot continue to test one chemical at a time. We need high throughput methods and the ability to test chemical mixtures. And as you heard from Dr. Goodson this morning, we need better definitions of what is a carcinogen. But we know cancer development is usually multi-step, and that steps can be triggered by different substances. I'll give you an example from ultraviolet light. UV can act as a complete carcinogen. It can actually, by itself, cause cancer. But it can also serve as an initiator. A low dose that does not cause cancer can cause cancer in conjunction with chemicals that cause inflammation. It can also serve as a promoter. It itself does cause some inflammation, so if you give a chemical insult that is not carcinogenic and you treat with low doses of ultraviolet light, which is not by itself carcinogenic, you can get skin cancer development. And by virtue of its immunosuppressive properties, ultraviolet light can facilitate the growth and development of other kinds of cancers induced by totally unrelated agents. So this makes deciding what is harmful a really complicated and very daunting task. Third, I think prevention is really quite a difficult field. I have to admire those people who work in prevention because it often takes decades to see the impact of removing a carcinogen from the environment. We heard this morning it took years to demonstrate a reduction in lung cancer incidence and mortality following reductions in cigarette smoking. So we need more surrogate endpoints for exposures reduction and reduced cancer incidence. And also, success in research is measured by visible achievements, as all of us in academia know. And so investing time and energy in projects that take decades to complete is not an effective pathway to a successful scientific career. So prevention of environmental carcinogenesis is also contrary to many commercial interests. Petrochemicals, pollution sources, pesticides, and even food additives all have strong commercial backing. And finally, prevention has no face. Cancer treatment, on the other hand, deals with real people. Patients and survivors have a voice. It's personal. Treating someone with cancer is a partnership. Curing someone or being cured is a personal triumph. So cures are associated with a high degree of motivation and a sense of urgency. Prevention, on the other hand, deals with populations, not individuals. It's not personal. We don't know whose cancer was prevented, and it takes a long time. So there's not the same sense of urgency about something that's going to happen, maybe will happen in the distant future. And I think most importantly of all, there is little federal funding to support this type of work and almost none from industry. These are the two major sources of support for cancer research. So if we are to deal with the problem of environmental carcinogenesis, we need to raise its visibility and increase the sense of urgency. We need to, as Dr. Bay said this morning, we need to change the narrative. And we must find some new innovative ways to screen chemicals for their cancer-causing ability, to study mixtures of chemicals, to redefine carcinogens, and to design studies that will provide answers in a shorter period of time. And we need to find the funds to do that. Thank you very much.